Hello once again. My name is KanstantsinNikalayenka. I'm Java developer and I have master's degree in data science. I finished it in Harbor Space University. So I'm also really enthusiastic about LLM and all this stuff. And today I will show you RAG and some techniques that you can use with it. Here you can see QR code to my repository. And for these people who still struggle with cloning GitHub or running some Python scripts, in my repository you can find a detailed version of setup of the project. So after workshop, you can go through it and try to install it. And now please don't try to do this because it will take from 10 to 30 minutes first time. So please now just focus and follow me during the workshop. So in my GitHub, you also see project structure. Here is all folders and all descriptions of what you can find there. And mainly we will work with main.repeater notebook. Will work there. In SRC, you have different folders with completed solutions that you'll see in main, but they will be separated like a real project. Okay. So here we are in main repeater notebook, and to start, I want to mention a few things about repeater notebook. So repeater notebook is mostly for making some researches. Cool tool for trying, debugging all stuff because it's interactive and you can save variables, write in memory and do whatever you want. But usually when you have a production product, you don't use repeater notebook, you use full Python files. That's why in SRC, we have folders with full solutions. So it's just my point. At the very beginning of the repeater notebook, I recommend you to put all imports. As many as you have, you will put them here, just not to waste your time afterwards looking what is going wrong, why don't have, why something is not working, and all this stuff. So let's run it. To run it, just Shift Enter or Command Enter. Yeah. Second cell is for global constants that you're using everywhere. So here I'm just loading Anthropic API key from environment. Let's run. And here we start with actually Anthropic calls. Anthropic calls is a class that I have made, and we will use it to chat with our LLM. And let's go, let's look through this class. So at the very beginning, we define a function init. This function will be class called each time you make a new instance of this class, and we define some parameters, self-is parameters that should be defined in all functions of the class to access the variables that stored in this class. Then name, this is just name of our calls instance. API key, we will pass API key here. Model, we will use Cloud 3.5 Sonnet. Maximum number of tokens. Default value, I set 1000 temperature. This is how close model follows your questions and how enthusiastic it is. So system prompt and stream. Stream is in case we want to have stream conversation. So all characters will be streamed as soon as we get it from LLM. Here we just assign all these variables to class variables. So self.name is class variable that will contain whatever was in a local variable name. So we just assign all these variables and make a new variable, self-history. This will be list where we will store all our messages to LLM in our conversation. And we are making client, initializing client, self-client, Anthropic.Anthropic. So from library Anthropic, it was imported here, yeah. We are making client and passing API key to connect actually to our LLM. Second function is add message. Here we also have self as in any function in our class. Then we have role and content. So role is whoever sends a message. It can be user, it can be our LLM, and content is actually content of the message. So it basically, most of the time, it's just text of what you ask LLM. Then we have clear history function. It will simply clear all the history, erase everything. And here we come to the functions that we will use mostly, the chat function. Chat function will give us possibility to chat with LLM. So we pass here message and some keyword arguments. So when I put like keyword arguments here, when I call the function, I can add as many arguments as I want, and all these arguments will be passed later to another function here, you see. So at the beginning of the chat function, we add a message. So we add a message, user message, with role user. So as you can see, we have role user and content will be just our message. And then we call getResponse function. So getResponse function is here. Here we have some parameters like should print. So we're defining if we want LLM, our class actually to print right away what LLM answers. By default, I set true because we want to work in interactive mode and see what LLM answers us. Here is our keyword arguments. I'm making dictionary of parameters that I will later pass to LLM in our conversation. So I'm passing self-model. So this is variables I initialized before in .init class here. So here we are putting system prompt in different LLMs that different, but in Anthropic we need to put system prompt in parameters here, and we are putting all other params as keyword arguments. Then we are making two variables, assistance response and text response. Is just empty string variables. And then we actually have a conversation with LLM. So first of all, we just check if we have stream enabled. So if stream is enabled, we will call this part of function, and let's go through it. So if stream is enabled, we're using our client .messages.stream. So we are initializing stream, passing all our parameters as keyword arguments here, you see. And then we use this stream and using for loop from Python for loop, getting from stream all text content. So we'll get the text chunk as soon as it will come to us. And we append this text chunk to text response to get the whole text response of answer. And if we want to print, if we have should print function, we just print it right away. And using flash keyword for Python to show us print right away. Otherwise, it will not show us print right away because the for loop and stream. So, and then we are getting assistant response after all message was read. So after LLM answered us this whole answer, we are using stream.getFinalMessage. And using this, we are getting all assistant response. If we have no stream, we simply just making self-client messages create. So we are creating message, put the same parameters here, and getting response, text response as assistant response.contact 0 text. If we should print, we print the whole response right away. Once again, if we should print, we just print here empty line to have some space between messages and add assistant message to our history. So this comment will once again add assistant message to our history. And let's run it and test how it works. So, okay, this is completed. And here I give you example how we actually use this. We are making instance of Anthropic calls called calls, passing only API key. All other parameters are by default, and just putting message hi. So calls.chat hi. Let's run it. Perfect. So here we see that this is our LLM sensor, and the second line here is actually specific of Jupyter Notebook. So whenever you have something at the very end of the cell, if you don't use it anyhow, so here our chat function returns us the answer of LLM. It returns as a result of getResponse function, and getResponse function returns assistant response. So this one is actually assistant response that is displayed just because of Jupyter Notebook. If you will run it as Python file, you'll not see all this stuff. So yeah, and about assistant response, I want to show you the structure. So you can see here, there are some different blocks, there are some different parameters here. So let me show you. So here we can see actually the structure of general assistant response. It have ID, it have model, what model answered, it have role, so it will be assistant role. It have stop reason. Stop reason can be different, like successful stop or tool usage stop or something else. I'll tell about this a bit later. Stop sequence, if you have any stop sequences, so you can add to LLM some specific stop sequence to stop when LLM just puts this sequence. Then you have type and usage. Also inside you have content, and content is actually list that can contain different blocks. The most common one is text block, so almost all LLM responses have text block, and we'll mostly work with it. It can be also something like image block or tool use block. About tool use block, I'll also mention a bit later. And now we will use text block. So actually, let's go back here. As you can see, to get text response, I'm using assistant response .content. So I have an access to this list. I'm selecting the first block from this list, first and only, because in our case we'll have only text, and put .text to get actually our text from text block. Okay, so and here we have simple conversation. Here's another example of this conversation. We make another instance of Anthropic calls and we put stream true. So now the response will be streamed to us. Let's run and check. So here you can see LLM is actually streaming the response. So it's not just collecting everything and just running, but writing right away. And here is our long abstract. And once again, our response. And here is a small while loop to make whole conversation, not just to send one message. So here we are once again making another instance of calls, putting n equal 20, making variable message that is empty, and while message is not equal end, we ask user to input message. This part is just text that will be displayed in your console terminal before you enter something. And here in Jupyter Notebook, you will not see it because of specific of Jupyter Notebook. But each time you run .py file, you'll see it. You can get rid of it. It's not necessary at all, but I just keep it to see what our program wants from us. So here I'm waiting for user to type a message, and then I just send this message, but I send it actually with some modification. So I make a string that starts with our message, and then I put small line like this, please use n words or less. So this is the first RAG trick I want to show you. This actually works really well. So when you use this technique, LLM will answer really with short answers. And if you want to restrict it with the size of the answer, you can use this. So let's put it as it is 20 and run once again. So first of all, let's type hi. I'm typing here in the upper corner, and here is our user replica. But when you run Python file, you'll have it in your console. So let's type hi, and here we have an answer of LLM, and it's actually really brief, you see. so it's not as long as it was before. So let's ask something like, how are you? Yeah, you see it's making well, and we have really short responses. So let's just end our conversation, and here we will first send end to LLM, and just after this we'll exit while loop. So we'll see answer of LLM to the end as well. So here we have answer of LLM to the end message. Yep. And let's inspect what is inside after this conversation, what is inside in our calls.history, just to understand what is there. So we have a list because of square brackets, and this list just contains such messages. So user message and assistant message, assistant response actually. So user and assistant. This is all our conversation. So this is the first point. Let's stop here. And if you have any questions, please ask.
Why you decide to use classes and to warp like the functionality inside of the class here in your example?
So using classes is actually good code organization in general. And here you shorten the lines of code you'll need to write, because we have a lot of code that will be reused. You can also set up your instances really simple with just parameters of the class. You could put whatever you want here and set up it really well. So it's really convenient to use classes here, and it's just good structure in general. So usually when you make a production product, you stick to using classes mostly, at least for such stuff as calling LLMs or maybe having SQL calls to database or something like this, yeah. Okay, if there is no questions, we can actually continue. Let's go on. And let's implement first rack. Actually, it will be not first rack, because this also counts as rack, because rack is actually a technique when you augment your message before sending. So this is really small, but still rack. Yeah, and now let's implement our rack. And to implement it, first of all, we'll make a class that will handle calls to database. So once again, the first function is init function, where we initialize all our parameters. Here we only need database path, because we will use SQLite. I'll tell you about this later. So saving this parameter and calling the function self.function. It means that we are calling the function inside the class. And so calling the function stop database and actually creating our database table if it's not exist. So we'll create table chat history with such fields, and I'll show them in a schema here. So here is really simple schema of our database, and we actually don't need something harder here. So we have only one table, chat history, ID of message, role of message, message by itself, embedding, and date of message. And why we have date, I'll show you later. We need it in general. This is good to have a date in any database and in any table, but here we'll use date as well. So set up in database using SQLite library. We imported it before in the first cell. Then second function we have is saving message. So we take parameters role, that is string parameter, message, also string parameter, and embedding. Embedding can be as vector as a string. So we are connecting to database and making try final calls. In case of any error, we will just close database connection, not to have any problems. So getting cursor, getting embedding in view of string. So if our embedding is vector, it will actually use JSON dumps function to dump it into string that will looks like in JSON format. Here we are checking if it's actually string or not. So if it's not instance of class string, as there is class string, actually type string. So, and if it's already string, we just put embedding as it is. Then we execute functions that will insert into our table role, message, and embedding. So I'm passing here role, message, and embedding, committing and closing connection. Next function is loading chat to data frame. So here we have actually only one parameter role, and in our data frame we have all database. We also have role field. Role field here is for user or assistant. So we'll save all messages as user messages as well as assistant messages. And when we want to retrieve messages, we usually want to retrieve only user messages or only assistant messages, depending on our case or situation. So here we are connecting to database, making some timeout, just not to be stuck. So, and if role is one of user or assistant, we are making a SQL query with where role is equals to our role, actually passing parameters like this. You always need a comma at the end here. So this one is really important. And if role is anything else, we just pass without selecting role. So we are downloading our database, and we are downloading it to pandas data frame using pandas.read SQL query. I'll show you once again. We have imported pandas. We have imported pandas SPD. So we just used SPD here, pd.read SQL query, and using this as query, we are loading everything in pandas table. I'll show you how it looks a bit later. Yeah, let's run this. So, okay. And now we need to make some adjustments to our class of Anthropic calls. So here we left everything the same, and the only parameter in init function we had self-embedder. And I'm using the same embedder that Dima was using before. So sentence transformer embedding function. Actually, there are a lot of embedders. You can find in the internet a lot of free embedders with different sizes of vector sizes, context sizes, and they actually fit for different tasks well. So you just need to find one that fits better for your task and use it. Yeah, actually, I have here also example of code for using Voyage AI from Anthropic. You can just uncomment this part and use it instead of this embedder, and just comment this one. But we will use this one because it's simpler and it does not require CPI key here. So then all other functions are actually the same except for chat. In chat, we have new parameter, clear after response, and by default it's false. So what it actually do, we have the same saving messages, we have the same getting response, but after getting response from LLM, if we set it to true, this parameter, we will clear all history of our chat. I will show you later why we need this. So in our getResponse function, everything is the same, and here we have small function getEmbedding. We have one parameter text, replace all /n's to spaces because it's better. No, it's just sometimes better. You can try by yourself to embed with /n's or spaces, but I prefer with spaces. So, and then we are just using our embedder, putting here text in list, because this embedder actually receives the list of documents and can embed few of them. And after this, we are taking the first result, because it returns also a list of results. So let's run it. And let's test it right here. Oh. So we make an instance of our new Anthropic calls and call function get embedding of sentence when is Apple conference call scheduled. And here we get our embedding. So it's actually vector of 360 something numbers. Okay. So here, first thing I want to mention once again about Jupyter Notebook. If you're using in VS Code, you have this blue line. You can actually click it and hide the output for you. Click once again and output will be here. This is really convenient sometimes, so I will hide this for now. And now let's make a break. Do you have any questions? Yes, Lucas?
Maybe just a quick question. So why do we need like SQLite, and what is the difference between like the normal SQL maybe in a short assumption, and couldn't we just store like the things in like CSV or something like this, or what is the benefit of using SQL?
Okay, good question actually, and this is next part I want to show you. So as I see no other questions, let's continue and let me show you. So we are going here, and here I have to remind you simple RAG schema. This is common RAG schema used everywhere. So you have a user in some chats, like when you have a conversation with ChatGPT or something like this, it works in some way like this. So user send us query, we get an embedding of this query, then we send this embedding to database with some specific query, and database retrieves us closest data. So actually what data we want to use in conversation with our LLM to remind it something. This is how RAG is used. Then we combine this user query plus data that we get and send them this message to LLM. LLM gives us response, and after post-processing, we just send this response to user. Actually, usually schema is a bit harder with more details, but I omitted them here. And this is like general representation of most of AI solutions, AI chats. So yeah, and actually I think that this schema looks like a bit as this rabbit, if anyone knows, but it's not that scary. It's really simple, to be honest. So, and in our case, we will have a bit different schema. Let me show it. So in our case, we'll have user that will send us query, and then we get embedding of this query. Then using SQL calls class, you will get all the data from the database. In our case, it's SQLite. We are getting all the data, and then we are sending all this data plus embedding. And using some function, we are getting similarity column. So for each row of the data, we are getting some similarity value, how close it is to user value. This is something that vector databases doing by themselves usually. So in Postgres, you have some vector columns and you can use some specific search. And in other databases, like in ChromaDB, all this done under the hood. But I want you to show how it actually works for you to have a deeper understanding. And it's not that hard, actually. And then we are getting top-end results from searching by similarity. Okay. Searching by similarity, we are getting top-end results that we need, build the message, send this message to LLM. Actually, we send in the whole history of all messages and getting response of LLM. Then some post-processing, and we are getting response. So getting back to SQLite, yes, we can store this data in some files like SVG or just JSON files or something like this. But in production solutions, you actually usually want to have a database, not to have too much files, not to have an interaction with different instances of your application, or maybe with different applications. It depends on your solution still. So, and SQLite, I use to show this interaction with database, but at the same time, it's really simple. It actually makes a file and nothing more. So it actually makes a file, and SQLite is actually name of database. The most common database that is used in the biggest number of devices all over the world, because it's really simple and it have no non-synchronized behavior, so it works only one operation after one. It cannot work in parallel at all. That's why it's not used in any like servers, but you can use it locally. And locally here I'm showing you an example using SQLite. So, and SQLite also cannot store vector data without specific configurations. So I'm storing our embedding in a text format. So here is actually text format. As a message also is text, and role is actually also text. Data is also text, but this is not that important. So, yep, and let's go ahead and look how we implement this part. So first of all, I make instances of already made classes Anthropic calls. Streaming is true by default. I'm setting streaming as true because I want to see response right away to not to wait too much. I'm making SQL calls with all default parameters, and by default it will make SQLite.db file where it stores our database. Okay, then I'm making some functions. So the first function is actually get context. So this function will make all under the hood actions. It will get context that we need. It will ask database, it will retrieve all data, it will sort this data by similarity and retrieve the number of messages we want that is closest to our messages. So here we are passing embedding. This will be embedding of user query or maybe LLM query if we have some specific examples, like Dima showed yesterday, some example when before getting embedding, you enhance user query with hypothetical answer from LLM. Then we have role, just to know what data to take. So in our database, once again, we store all messages. We store as user messages, as assistant messages. So here we specify if we want to take data only from user messages or from all of them, or from only assistant. And n here is a number, how many messages we want to retrieve. By default, I set 1. Let's check how it works. First of all, we are using our SQL calls to load chat to data frame. So here I'm loading everything to data frame and passing here role to load data only with specific role, as I mentioned before. And now chat data frame actually have data frame with all our messages with specific role. Then I'm getting context, the final context I want, using the function find top and similar. So here I pass our data frame with all messages, user embedding, and number of how many messages we want, actually. Okay. Then find top and similar. Here is this function. We are accepting data frame, user input embedding, and number. By default, I set 5, but here we actually will never pass something like never use default value because we are calling it from here. So then after accepting data frame, we check if it's empty. So if our database was just created, if there is no messages there, data frame that we get from load chat to data frame will be totally empty. So we need to check this. We also check if we have embedding column, because this is like crucial column that we need to find similar messages. And if it's not here, if our data frame is empty or we have no embedding column, we just print that the data frame is empty or missing embedding columns and returning empty data frame. So this function data frame is used to make empty data frame instance. Okay, then using such construction, so data frame is pandas data frame, and using such construction, you can access and edit one column of pandas data frame. So here we are accessing embedding column and applying to this column this lambda function. This lambda function is really simple. So we first of all check if our embedding is string, and if it's string, we load it to Python structure. So JSON.loads. Before we use JSON.dump to dump it to string, and now from string we load it to Python object. And in this case, it will be a Python array with float numbers actually. Yeah. So load as you can have just load, but here you need to specify where you load it to some variable, to file. And when you put load as, you load it like a string. So this function will return actually string, not string, will return a Python object. And if it's already, so if this one is wrong and embedding is not string, we just return embedding as it is. Okay. Then using this construction, we are making new column in the same data frame, similarity column, and how we get similarity values. Once again, we applying function to our embedding column. So embedding column will not be changed because we don't overwrite it, but we make new column here. And what we apply? We apply similarity search function that accepts input embedding, user input embedding, and embedding for this specific row. So for each row from embedding column, for each embedding from this column, we will apply this function and return it to the same row to similarity column. And similarity search is actually here. It's really simple. So we're taking first embedding, we're taking second embedding. So one of them is user embedding, second is embedding from database. We are reshaping them to the same format, to have the same dimensions, and then just applying assigned similarity from sklearn. So here from sklearn metrics pairwise, we applying assigned similarity. Actually, assigned similarity is really simple. So it's just multiplication of the vectors. And but here it also applies some normalization and so on. So that's why I'm using this function. And getting 0, 0, because cosine similarity from sklearn actually can work with matrices. That's why it returns as matrix. So we are getting this one. This will be number how similar our message from database is to user message. So returning back here, now it will be, all these numbers will be in similarity column. And then we just get in top n values from this column. We sort these values by similarity, all data frame, and using head n to get top n rows from it. And after this, I'm applying sort values by date. And why I'm sorting by date? It's really simple, because sometimes in your memory, in your database, you have a lot of messages that have some common sense. So, for example, in one message, you define some word, define the meaning of this word, and in another message you use this. So if we by accident, by any chance, get the messages that have connected to each other in any sense, that they will go in the right order, in the order they were sent to us. So we will know that they are going actually in right order. And we sorting by date here actually only our top n numbers. So we are not losing anything because we will return anyway all of them already, all that are in top n data frame. And here we are just returning it. So it's going back, and this will be our context that we found. So, and here, another one really important function, send message. So this function will handle all our communications from this point with LLM. Here is text. So text is user query actually. Clear after response if you want parameter. Then we are getting embedding of user query, getting context using all these functions that I showed before. And then we are saving this message right away. So as soon as we get the text message, we saving it to database, just to have it in database with date as close as it can to real one. After this, we are checking if our context is actually empty. So if there is nothing in our context, we just print that context is empty and assign text to combined message. Combined message is the last message that we will actually send to LLM, and text is user query once again. So, and if we have something in our context and it's not empty, we are going here. We are moving all from message column to the list. So it will be Python list that will contain all messages that we retrieve from database and things that they are similar actually to our message user query. Then we just print it for debugging purposes to see these messages, to show you these messages. And then we combine them in one string. We concatenate this with /n. So this will just move to another line after each message. So it will go like one message, then enter, other message, enter, and so on. And this context message we use to build combined message. Here we use some RAG techniques, provided context. Then we are putting our context message. And then we are putting user message and user query. Wait a second. So now our LLM, if context is not empty, will get a message that looks like this. And then we actually have a conversation with LLM. Once again, function chat. So we are sending combined message. And we are passing parameter clear after responses. Here I'm accessing once again the answer, text answer of LLM. I'm getting embeddings for this text answer once again and save these embeddings right away. As you can see, and returning this all LLM response. So let's run it. And small function conversation, I just put our while loop because we'll reuse it a lot of times. I'll just put it in conversation function. And the important point here is that clear after response equals to true. So what does it mean? This means that each time we send the message to LLM, right after receiving answer, we'll erase all history that we have in our LLM calls instance. So we'll erase all history, and next time we send a message, LLM know nothing about previous messages. This is important to show how actually RAG works and that it works. So let's run it, and let's run the conversation. So here I have key points repeater notebook, where you can see, this will be needed a bit later. So I have prepared messages, some prepared messages. First message: hi, my name is Peter, and I really like Choco. Let's send it. And we get, so the first line is data frame is empty. So in our database, here is it. It was created. Let's see. It was empty right after this message. Then we get no context because there is nothing to get from database, and then we just get a response of our LLM. And now, after this conversation, we already have 2 rows in our database. So in our database, we can see here ID, role, message, and embedding. Here, embedding, it's actually a vector, as you can see, and date. And here is like my message. And here is assistant message, assistant response that was saved to database. Let's continue. So now we can close this. Let's send the next message. Now, can you describe a beautiful view on London? Let's make it as a scrollable element to see all. So here is our message. Then we have context. So in our database, we have, once again, I'll go up. So let me show you, get context. So here in get context function, we actually ask for all messages with role user. So from database, we are getting all messages with role user, and top 3 are closest to our query. The idea here is that we only have 1 message for now, so we are getting only 1 message, and only 1 user message. It was just previous user message. Then we see the first problem. LLM apologized because it does not see any connection between context provided, this context, and our question about London, but it actually answers question about London here. So this is already 1 problem. Then let's send another message, like really popular question. Hi, today I want to have some ideas how to make a lot of money. Let's send it. Here in context, we see 2 our previous messages. And once again, it have no ideas about why this strange context is here, but it answers our question. Let's send the last question, 4th one. And now we can see in our context, we have all 3 previous questions. So, and let's go to SQLite. And now here we have 8 messages, 4 from us, from user, these 4 messages, and 4 from assistant. All they were saved. And let's stop the conversation here. For now, we'll continue it later a bit. And here I want to show you actually how our context looks like. So I'm making 1 new LLM calls instance and using function get context. So here I'm putting embedding of the question, what is my name? Taking all messages from database with role user and putting that I want to have 3 closest messages. And in our database, we already have 4 messages with role user. So it will select only 3 of them. Let's run it. And here, as you see, this function returned as context And this context was not used anywhere, so it was displayed because of Jupyter Notebook. And here we can see it's actually a table, pandas data frame, as I told before. And here we have some columns and rows. So messages, embedding, date, similarity. And we can see even similarity, how similar this message to answer. So this message was most similar. This was second one, and third one was already not even close. You see, it's only 008. Because it's not connected to name anyhow. Yes. So now let me show you. Let's, for example, copy what I made before. Here. Yes. So we have our context, and I'll show you how. Oh no, I can just show you like this. Look, so once again, reminder, this function will return a pandas data frame, that is context. Then we can use such construction as message, and we'll get only message column, just to demonstrate. So here you see we have only message column. When we use it to list, it gives us Python list with these messages. So this is how it works. For you just to have in your head understanding how it looks like and how it works. The same is with similarity column and others. So if you want, I can actually take similarity here and provide the same trick. Hop. And we have like three list with three numbers. Okay. And let's continue our conversation with ESLM shortly. Let's run it. And here I have some questions prepared. So first question, do you remember my name? Once again, reminder, we are clearing all history, so LLM does not remember anything. I mean, in our LLM calls instance, nothing is stored connected to the history. So history is actually empty. And now when I ask, do you remember my name, it can get this only from context. So let's run and ask. And context provided, as you can see, there is three messages, closed messages, and first one was actually about my name. So it actually answers me shortly, yes, I remember your name. You mentioned that name is Peter. So RAG works perfectly. Let's go. So next one, do you know anything about my pets? And here's context provided once again. As you see, the last one is already question from the previous question, because it was also saved, and now we retrieve it as a new context because it's closer than other one. So, and yes, LLM knows about my pet. You mentioned that it's scared. I have parrot named Coco. Oops. So let's ask the third question. Not connected to anything about our, not connected to anything from our context, because we have nothing about atoms. And here you see context was provided. Let me show you. The context was provided, this context. And LLM apologized, it does not actually have any ideas why this context is provided when I ask about atoms, you know. So it's not that convenient. So this is one of the problems of this approach. But it actually answers about atoms. And now another problem. Once again, I'm asking about my name. And here we have no sentence, no message with my name in context. Why? Because all these three messages appeared to be closer by embeddings than message with my name. Why? This one, I think it's just by luck. So just by accident is closer one. And these two, just because it's questions. And question, do you know my name, is actually closer to questions, do you remember my name, or do you know anything about my pets? So embedding side, it's like embeddings think that we need this one because they are closer by embeddings, but it's not actually what we need. And this is a big problem because now our LLM is not that clever. It cannot answer anything about our name. And if we repeat this a few times, like with different type of questions, what is my name? The same questions were provided. Actually, not the same. This one was changed to the last question I put to LLM, you see. When I ask something like, my name is what? To provide something really similar because my message with my name started with my name is, and once again, we have nothing. And here, now we can see only questions. So this is actually a big problem because, so we can imagine a user have a conversation with LLM in all chats, and he asks one question a few times. So next time he asks this question, most of the context he will get by embeddings will be his previous questions, but not the answers to the questions. And this is really like real threat. So let's stop here and have a pause. Do you have any questions? Yes, Samuel?
Hi. Can you set it so that it doesn't embed the questions, or rather just if it's information? Can the
Yes, you can set it. You can make some regex expressions. You can make some checks and so on. But it's actually much harder. And I will show you I will show you a few ways how to actually fix this. Yes. So it will be right after this one. Do you have any other questions?
Yes, we have one question, one quick question actually from the chat. Where does the pop-up window come from? Is it from the conversation function or it's related to the VS Code? As I understand, it means about the chat, like pseudo chat UI.
Okay. You are asking about this one pop-up question.
I think it's like that. Yeah.
Yes. Okay. Yeah. This is from VS Code, and this pop-up window it's specific of Jupyter notebook in VS Code. So if you have just Python, you'll not have this. .py file, and run something. You have all this in your terminal. You will have no pop-up window. So let's continue. And give me a second. Something I want to mention. Okay. Okay. So I will also make a small point here. Return to our first class. And I want to mention one other thing. So here in our class, using our while loop, we can have flawless conversation with LLM, and it will keep the history and each time send the history to LLM. But here is one problem, and not only one, because I'm just skipping some moments that are not key moments to this workshop, but they are really important and you should remember about them. So here, actually here you need to cut your history if you have more tokens in it, then it's provided by LLM. So LLMs actually now have some interface, so they cut the history by themselves. But for you, it's much more convenient to know what you actually send into LLM. So here in chat function, after adding message this one, you want to make some function that will, for example, trim history. So this function will check if this function will check if history is long enough, and if it's long enough, it will just delete first questions, or it will make it in some other way, compress it somehow. It's on your side, so you need to decide. But this one is really important to mention, because otherwise, at one point, you'll see the problem that you can get an error, or you can get an unexpected behavior from your LLM. It depends on LLM, actually. Okay, now I need to say that we are already lacking time. So if someone needs to leave, you can leave, and we will continue with some other tricks. So we finished with the problem with our questions. So we have too much questions, and we lost our context that we want to see. So wait a second. Okay. So it's not convenient at all, to be honest, this solution. When you save everything, you can actually try to make some better prompting techniques. You can make some regular expressions, but it's also not working all the time. So here is one of the solutions, keywords. Here, first of all, I'm making another instance of SQLite calls, and I pass keywords.db. So I will make a new database. It will be stored in another file. And then I'm just adding some changes to send message function. So here, at the very beginning, I have a list of keywords, such as remember, memorize, and learn. Then the same I was doing before. I'm getting embeddings of user query, getting context, all the same. And here is actually a new part. This condition checks if in our text, if in our user query, we have any of these three words, any of words that actually in keywords. So if we have remember, memorize, learn, or we can even add some other words we want. This function will check if in user query such words appears. And only if we have these words, we save this message to database. Otherwise, we are not saving anything. Then the same situation with context. We just check if it's not empty. And LLM conversation, also minor difference. So here we also get LLM response, but we are not saving LLM response because we are not using it. We don't need it. So we just don't call once again as SQL calls save message. So let's run it. Let's see that this line works well. We can open files, and here we have keywords database. Let's open it. So here is our chat history table, and it's empty for now. So it was created. Cool. Now let's start conversation and check how it works actually. Boom. Oh, so I have some prepared messages here. Let's copy it. The first message, I'm starting with keywords remember, and you can see I have it in different register, but it will still work and see it. So remember that my name is Kostya and my dog's name is Pet. Sending this message. The first response was data frame is empty because in our keywords database there was nothing before. Context is empty, so we are just sending this message to LLM, and LLM answers us, certainly I'll remember that your name is Kostya and your dog's name is Pet. So here you can see LLM's answer. Yep. And other question. So let's open database, check it. Yeah, and in database we already have only this question. We also don't have assistant response here, so it's does not exist here because we are not saving it. Yeah, let's send other question. Let's say send something like, I really like reading books, please remember this. And let's check. Context here is our previous question. because it's the only question in, not question, previous query, because it's the only query that we have in database, only user message. And then it answers us, it will certainly remember this. And let's check database once again, and it's here, you see. So let's add the last one I have here prepared. And I put that, remember please that I'm really, really passionate about atoms. So it works well. Once again, cool. Now let's try to ask some questions. So first question, do you know my name? And our context provide us with, remember that my name is Kostya. And here you see we have only 2 lines. Why we have only 2 lines? Because here I changed n to equal to 2. So now I'm retrieving only 2 closest messages, not 3, just to showcase. So yes, and it answers correctly. Cool. Let's answer other question. Do you know something about my interests or maybe hobbies? Context was provided about that I'm really like reading books and that I'm really passionate about atoms. And actually, LLM sees this and answers perfectly. Cool. Let's continue. Next question. Do I have any pets? Yes, I have a pet dog named Pet. So it works really good. And now let me show you downside of this solution. It still has some downsides. Tell me something about Minecraft. Oh, I missed C here, but whatever. And look. So I ask, tell me something about Minecraft, and my context is these 2 lines. And these 2 lines are not connected to Minecraft at all. So actually, this is context that we don't need. One solution is to make some threshold. So we are making threshold, and if similarity is lower than this threshold, we are not putting these messages into context. But this solution also can sometimes work not that well. So I will show you the other solution afterwards. And here even LLM answers like, well, it's not directly related to your love of reading books. So it sees that context is not actually respond to the question we want. But it answers still really well. Let's end. And do we have any questions? Okay, I see question. What type does the similarity search function input and output? Let me quickly head to this function. So similarity search returns actually one value. It returns float number, and it receives 2 embeddings. And embedding is actually vector of float numbers. In this case, it's Python list of float numbers. So this one is list of float numbers, and this one is list of float numbers, and it returns float number at the very end. Okay. So any other questions? Let's continue. So now I want to say that I really think that keywords is valid solution, and sometimes, for example, if you have your own LLM application on your side, when you have it locally, for example, and you have, for example, knowledge data set using LLM to fastly get data from it and so on and so on, this approach can be really good. So, but you should check yourself not to write these keywords by accident, for example. But in other cases, when you don't write it by accident, this can be really reliable to make some LLM helper for yourself. And you can actually use some free LLMs as well to not pay for tokens. There are a lot of LLMs that can be even self-hosted on your laptop. So this one is already a reliable approach, but there are some better, and I'll show you them. So let's head to another one and let's add LLM determination if context is relevant. So the last point I showed you that sometimes, and actually a lot of times, if we have no context related to the topic, or we have context that seems related, but it's not actually related, it can actually provide us, and it will provide us with context that is not related to the topic. And this is not really good. It just makes sense more tokens to LLM. It can make it seem in some other way and give us some problems, So here's how to avoid this. We are making new instance of Anthropic calls, and this actually have more parameters than before. First of all, we pass API key as usual. Then we pass max tokens, and I just, instead of 1024, I decided that we need less tokens for this one. Then we put system prompt. A second. And system prompt is here. You're a helpful assistant that determines if a chunk of text is relevant to a given query. Respond with JSON object containing a Boolean is relevant field and a reason field explaining your decision. So here we actually don't need a reason field because we will use only is relevant field, but making some reason field is better because LLM tends to add reasoning to its answers, and this can be bad in some cases. So here we want to have a valid JSON object, and if LLM will add some reasoning not inside JSON, but it will add reasoning by itself, like Python comment inside of JSON or something like this, this JSON will become unparsable. And this will break our program. So that's why we are putting reason field here to not have this problem. Actually, this also is a good place to apply the technique I showed you at the very beginning. So technique when you print something like please use n words or less for you to have smaller context, because in our JSON object we'll have only Boolean is relevant, and Boolean is just one word, so it's perfectly fine when you restrict his answer to something like 20 words. So you'll not use as many tokens as you can. Then we are making function is relevant. We send a chunk from database and user query. And this function will check if this chunk is actually relevant to this query. How we do this? We are using this instance, context determinator, chat function, and sending this message to LLM. First of all, we specify the query, put the query variable here, and then specify the chunk. And then ask, is this chunk relevant to the query? Respond in JSON format. So we have this in system prompt, but we still want to repeat this once again in our user message for LLM not to forget about this, because LLM can easily forget about this message. So should print false. We don't want to see prints of this because we are not interested. Clear after response true. So we clear the history. We don't want to we don't want to keep the history of determination. It's useless for us. Then we print this chunk just to see what was the chunk and a response of the LLM to this chunk. So what it actually answered. So we can use should print true here, but in this format it's slightly more visible. And then we just return Boolean value. So we are getting text response using context 0.text. So we are accessing text inside our response, load it as Python structure. And in this case, it will be dictionary because it's JSON. And we access field is relevant. So we get the value inside the field is relevant. So this function will return us true or false. Like this. Okay. Then we have some changes in our send message function. We are keeping keywords because this is the good technique. And if our context is not empty by default, so here we are getting our context from database, the most relevant context. And if this context is not empty, we are going here, and here we are putting it in a list, making new variable cleared context. This is empty list. And for each context chunk in context messages, so in our list of retrieved messages from database, we are checking each message if this message is relevant. So if is relevant to the user query, text is user query once again, then we append this context chunk to cleared context. So it was empty list, and each time we see that context chunk is relevant to text, we append it to cleared one. And then if we have at least one message in cleared context, we are building combined message. If there is no messages in clear context, we just put in user query without anything and getting a LAM response. Let's run it. So I also have some prepared messages here, and you also get access to all these messages. They are all in GitHub. So first of all, let's write something like hi. And here we will see how LLM think actually. So hi, and we are getting 3 chunks. First chunk, remember that my name is Kostya and my dog's name is Pet. And LLM thinks that this chunk is not relevant. So response of LLM is this one, actually value JSON structure. It's not relevant. And here is reasoning why it's not relevant. So it's actually give really good reasoning about it's not relevant with really long response. So you really want to add something like, please answer in 20 words or less. Then other chunk, reading books, is not relevant. And other chunk about question about atoms is also not relevant because it's just simple hi message. And then here we have a LLM response to our hi. Hello, how can I assist you? Okay, now let's ask something about atoms. So here we get also 3 chunks. First chunk about my name, not useful. Second chunk about books, not useful. And third chunk that I'm really passionate about atoms. And here we're getting true, you see? So as we are getting true, now we have some context. And this context is actually the message with atoms. And then LLM answers us, I'm glad you're passionate about atoms. So it's not only see our question, can you tell me something about atoms, but it also sees from our context that I'm passionate about them. So it answers using this context. So it's more user-related answer, as you can see. And now let's ask about my pet. Do you know about my pet? And once again, 3 chunks. The chunk with pet is relevant, and 2 other chunks are not relevant. So this one is relevant. And in context, now we have only one message that is relevant. And it prints that it's dog named Pet. So it's really good. And this is already like stable solution that you can use. Let's end conversation here. Do you have any questions? Let's continue then if there is no other questions. And we are actually moving to some last seconds here. So this is actually really cool and can be really useful in many cases. It works with actually determination if chunk is useful. Determination is using LLM once again. And now we are making a user data extractor. So now instead of using keywords, we will try to extract user data from user queries using LLM. So now LLM will decide if user query contains something useful for us to remember. So first of all, we are making new instance, and you can see how reliable is it. I'm using class, and I only need to make new instance, and all stuff is set up right away. I don't need to clone this long lines of code and so on and so on. I can just reuse it, and I have few instances. So I have instance LLM calls is just for chatting with LLM. I have user data extractor here, and I have also context determinator, and they all work at the same time, and they're working without any problems. So here I'm making user data extractor, putting max tokens to 1000, making a system prompt. You're a helpful assistant that extracts chunk of user-related data from a given query. And here we will use another tool from Anthropic. So when you are using Anthropic interface, you can provide tools to your LLM. And here we are making extractor tool that we will provide to our LLM to use. So let me show you how actually tool structure looks like. So each tool you are creating is Python object here. It's dictionary actually. It have values, fields name, description, and field input schema. In field input schema, you specify type of inputs that you want to get. So let's go back. First of all, name is name of your tool. So here I specify that name is safe extracted data. My tool name is safe extracted data. Then description, I give a description, and this description should be really good. So you should specify what this tool is used for, when it's used for, and all stuff connected to it. So in what scenarios you need to use, in what scenarios you don't need to use. And here I use only one tool, and this one is really simple. So I don't need to specify too much, and I specify just save a given data extracted from the user's query. So this is description of the tool. And then I give input schema what my tool needs to receive. So it's like function that have some fields to receive, and I specify what fields I need to receive. First of all, I specify the type of it is object, and then I specify properties. So let's have a look here. Type of is object, and then we have properties. In properties, you put as many fields as you want. So put just field name, then type of the field. It can be string, it can be like image, maybe. If you're passing images to, if LLM need to pass image to your tool, and description. So description, you describe what this field actually means. So in our case, we have only one tool, one field chunk, and it's type string, and description is extracted data. So all extracted data that LLM extracted from our query should be passed as chunk parameter. And then we have required field. So here we list all required fields, and I have only chunk, that's why I have only one. And here's also example, like required, it's list of required fields, and you can put field name 1, field name 2, and so on, as you can see. So this will be our tool. Then we are making extract user data function that receives query. And then right away we chat with our LLM. So first of all, we make a string that puts like query is this query, and ask it to extract user-related data from this query, use tool to save it. We specify all this in user message. Then should print true, we don't need to print, and now we specify tools. So tools is list of tools you want LLM to use. And here I specify that it should use extractor tool. And then I clean after response. So here, now, after I'm getting response, how I should recognize if LLM decided to use a tool. If LLM decided to use a tool, then stop reason will be different from usual one. So usual one, let me show you here. When we get a response from LLM, there is a stop reason. Oh, this one is really long. So we have stop reason and turn. And turns means that this is normal stop reason. LLM answered everything it needed and it ends correctly. As I showed you before here, stop reason is one of these fields. And if we use tool, let's go back to the tool. Yeah, if we use tool and LLM decides that the tool should be used, stop reason will be tool use. Then we need to check all items in content. So content is actually list that can contain text block, image block, tool use block, and it can be few blocks in some cases maybe. So and we need to check each item from the content. And if item dot type is tool use, so here you see type is tool use in tool use block always, then we want to check if item name is actually our function, so saved extracted data, so the name of tool we provided to LLM, and only then we use the tool. And here tool usage is in that way that we just print this block, tool use block, just for us to see, and we just return it. We are getting our chunk. So tool use block will contain ID, it will contain input, and input is what LLM wants to pass as parameters to your function, and name. Name we checked already that it's our name, and we are using input. Then dot get. Here I'm not using like square brackets and chunk, because in some cases LLM can just don't put this field, even though it's required. In some, just to be safe, I'm not putting square brackets, because if I put square brackets and this field is not existing, then we will get an error. So I'm using get function, I'm getting chunk, and if there is no chunk, I'm just returning false. And if any of these ifs was false, I just return false. So there was no extracted data. And here is changes to send message. So it's actually simple. I'm commenting keywords. We are not using them anymore. I'm getting embedding of user message. I'm getting context. And then I'm extracting data. So I'm using this extract user data, putting user query. And here in extracted data, I will have false or our data that was extracted. So if it was false, it will not enter this if. And if it is data, it will enter and save this data in database. And all other parts are the same as it was before. So let's run it. And let me show. So in our database, now we have 3 messages. These ones. And now let's have a conversation and let's try to add some messages. First of all, let's type hi. So here, as you can see, before chunks, there were no any tool used. All chunks, once again, decided that it's not relevant to context. So we just get answer from LLM. And there was no tool usage messages. Then we ask, for example, then we provide something to LLM. I will say to LLM that tomorrow I'll go to dogs exhibition with my dog. So here I'm testing 2 tools. First of all, will it extract any data from this message and save it to our database? And second, will it remember about my dog? Let's check. So this message sent. Let's open as a scrollable element. And here we see. So this is our question message. And tool use. So tool was used. Tool use block we can see here. And we can see what was input. Input was like this. We have chunk field, so everything is fine. And in chunk field, we have user has plans for tomorrow to attend a dog exhibition. User owns a dog. So now it wants, it will save this to database. Let's check. We had 3 updated, and now we have actually 4 messages. So we have this message here. User has plans for tomorrow to attend a dog's exhibition. So this works fine. And then we check our chunks determination. So the first chunk our rack retrieved was, remember that my name is Kostya, and it was relevant. And LLM decided that it was relevant. So we have context provided, and our answer from LLM is really personalized now. So first of all, it sees that my name is Kostya. That's exciting, Kostya. It sounds like you and pet. So I just told that I'm going to exhibition with my dog. I don't specify the name right in message, but here it uses message. Here it uses name of the dog, and that I will have great time in dog's exhibition. So it works really good. Okay, let's try to something else. And this one is a bit trickier. So here, and a week after that, I will visit scientific conference. Can you guess what it will be about? So actually, here in mind, I have a conference connected to atoms. Yes, and it needs to guess. Will it guess or not? Let's check. So here we have our message. Then it actually uses tool. So it saves this chunk of data. It extracts and saves this chunk of data. User plans to visit scientific conference. Let's check. Yes, we have new line in our database. Then we have chunks, and it's checking if it's relevant. So here we have chunk about atoms, and it thinks that it's relevant. You see, the chunk is relevant to the query because it provides hint about the potential topics of scientific conference. And you're actually lucky because all previous times when I tried this, it says that it's not relevant. So here, then we have like this context provided about atoms, and it actually guesses that topic probably related to atoms. So conference might be related to atoms. It guessed correctly. And all other attempts, all previous attempts, it was not able to guess because determination decided that it was not relevant. So let me try to reproduce this to show you that it's not always that reliable. So let me copy this query once again. Here, I put it here. And let's check. So yeah, and now you see here, remember please that I'm really passionate about atoms. It's false. It's not relevant. It seems that it's not relevant. And only here is what I previous time saved about I'm planning to visit a scientific conference, but it does not contain anything about atoms. So here LLM will answer us that it does not know. Let me send another message. So, and I prepared another message here with hint. So I put at the very end hint, it's connected to one of my interests. So with this hint, it's definitely will understand. So here it's like, I'm excited that I will be attending a scientific conference, but however, I don't know, I don't have enough information to guess a specific topic. And when I provide him hint, it actually it actually uses tool once again and actually thinks that it's relevant. Okay, do you have any questions here? Yes.
Sorry.
Yes, Lucas.
Yeah. I have the question. If you specified that the max token of the context should be like 1,220 or something. Is it easy to go over the threshold with applying a lot of context to the question? And do you make a maximum amount of, things regarding the topic that the context should be included in the context?
So first of all, this 1024 is threshold for answer. So LLM will answer using no more than 1024. For general context of what LLM receives from us, the history in modern LLMs, it's really big. It's thousands of hundreds. So in how it's called in Anthropic one, it's really big as well. So usually you can put a lot of documents there in a context and send this to LLM. But you still need to it's not that easy to go out of it. But if you have really big database and in production cases, you need to monitor it by yourself. So you need to cut some unnecessary things, and to actually use all this stuff to do this, you want to specify this number n. So you specify how many chunks you retrieve from your database, and in your database you usually have chunks of some specific size. So you know that in your database chunks are not longer than 200 tokens. So you can retrieve like 500 related 500 related chunks. It's really too much, I think. Usually you don't retrieve so much from memory, but it depends. If you have some scientific papers or you want to make fully automated scientific researcher, you could face such situation. So, and you can calculate that 500 multiplied by 200 and you'll get like 100,000. If I'm calculating it right, yeah, you'll get 100,000, and it's still lower than your threshold of LLM, how much tokens it can receive. So you can control it with this number.
Okay, thank you. Yeah, and maybe just one more question. If you go over the threshold of the tokens you said at the beginning, what would happen?
So this actually depends on LLM. Anthropic, if I remember right, it will send you an error message. It will send that, sorry, you have, this message is too long, I cannot answer it. ChatGPT acts the same. Llama can just, if I remember right, it can just throw some errors, but it will be like, it also retrieves you because you send it as a request, so you get answer to your request that the operation was failed, something like this. Yes. So from Anthropic and GPT, it will be like an answer, and also you'll have specific stop reason. You can check all this in Anthropic documentation, and I also have here a link to Anthropic tool use, so how to use tools, some more examples to have, because this one is actually really powerful tool to pass tools to LLM and use them, and you can actually answer LLM. So LLM asks you that it wants to use tool, and then you answer as a result of tool, and it continue doing what it was doing before. Yeah, that's also possible. So, okay, no other questions. So then I will show you the last part, the really last part. I will show you one small technique. It's really new. Anthropic posted paper like 1 week ago, I believe, about this part. So I just take an article from Wikipedia about atoms here. This is long article, as you can see. I put it in a variable article. Then I take one chunk from this article. It's just one paragraph. Yeah. And then I make such message. First of all, I'm putting this for LLM to understand that it's document, putting my article here between this text, XML text, and then I'm writing there. Here is a chunk, and we want to situate this chunk within the whole document. I'm providing the chunk. So this is actually paragraph from the document, and the document contains this paragraph. So here there is a chunk. And here, please give a short, succinct context to situate this chunk within the overall document for the purposes of improving search retrieval of the chunk. Answer only with succinct content and nothing else. So I want to have a short answer about location of this chunk. So let's run all this. And let's just ask without any loops, let's just send one chat message. So I send this message. Here I actually can lower this max token, it's not needed to be big. And here I have an answer. Let's copy this answer. So, and we can read now. So this chunk appears in the selection describing the basic structure of and properties of atoms. It provides key information about the mass distribution. So this paragraph can contain some words, something that connected to all article, but it's not stated in the chunk itself. And why it can be useful. So you actually, here I have example of pipeline where you can try to use it. When you have a lot of documents, and when you load your documents to your RAG database, you split these documents to the chunk, and for each chunk, you generate such a small paragraph. Then you concatenate this chunk with paragraph. So first it's chunk description. This is chunk description paragraph, and then your chunk, and save it like this. So your chunk will be a bit bigger, and you should remember about this when you calculate the size of and decide how many chunks you want to retrieve. But now, first of all, embeddings will be closer because embeddings now have a context, have this context about this chunk, and they can actually determine if this chunk is really related to this topic. And also, when you send this to LLM more closer understand how this chunk is used and what is used for. Yeah, yes. So, and here I have small exercise for you. So I show you this technique, and you can, if you want, try to implement it or make some pipeline as I made before. So you can have a whole conversation, and it will use this technique with chunks. Relevance, or make something like here when you can load few documents using these examples by yourself to train the skills. So actually that's all. Thank you. If you have any